Hello guys, what we have here is a question 2018 GATE exam question. That's what we have here. And now what they have asked us is that we are given vectors v1, v2 and v3. v1 is equal to I cap minus j cap, and v2 is equal to minus 2I cap plus 3j cap plus 2k cap. Okay, and we need to find out v3, which can be called as x I cap plus y j cap plus z k cap. Okay, which we need to find out, which the only thing that the constraint is to make sure that vector v3 combinedly form v1, v2 and v3 form a real linear vector space. Okay, if it's a real linear vector space, which means a three-dimensional real linear vector space, which means the terms have to be independent, which means that the determinant of v1, v2 and v3 must not be equal to 0. That's the only condition for a real linear vector space. Now let's check it out. Okay, first of all, we can take the terms of v1 and v2 and form a matrix equation. Okay, so first one is I minus j, which means 1 and minus 1 and then 0. And for v2, 2I, 3j and 2k, which means minus 2, 3 and 2. And for v3, you can write down x, y and z, which must not be equal to 0. The determinant of this must not be equal to 0. That's the condition. Now let's find out the determinant of these things. You can write down 1 times 3z minus 2y is the first term, and then again minus of minus, which gives you plus 1 times 2y minus 3x, and there is a minus sign, of course. This is the determinant, and then 0 times this will vanish. Now, so the equation has to be simplified a little bit, of course, and you can write down 3z minus 2y minus 2y minus 3x will be the equation, which means it will be 3z minus 4y minus 3x. That's the equation right there. Now let's see what we can do afterwards. Okay, what we can do is that we can substitute the values. Alright, I made a mistake here. You can see it's not 2y, but this time times this you get 2z. Okay, and 2x, right? It's 2x. Oh, my bad. Forgive me for that. It was for this term you have to multiply these terms, right? Now making that correction all together, you get 2z minus 2x, right? So it's 3z minus 2z, you get 1z minus 2y, right, minus 2x. So that's it, 1z minus 2y minus 2x. It was my mistake and I beg your pardon for that. Now it can be written as minus 2x minus 2y plus 1z. So this is the determinant of this matrix, which means now what we need to do is that now let's substitute the values of each of these vectors to see if this determinant makes it up to a non-zero element. Okay, so first of all I'm going to use the option first here, and you get for v3 being option A, you get 1, 1 and 4, right? 1, 1 and 4 for x, y, z. For that you will get minus 2 times 1 is minus 2, minus 2 times 1 is again minus 2, and then 4 times z, which is 4, which gives you 4, which will be equal to 0. So this is not the correct option, so we can use this option D. Okay, check it from the last option D, and you can see that you have to substitute 2, 1 and 4 for each x, y, z values, and you substitute that values in here and you get 2 times x, which is 2 again, which gives you 2 minus 4, and then minus 2 times y, which gives you 2. again with 4 in place you get 4, so the answer will be -2. So this is not equal to 0. Right, so option D is the correct answer, which creates the most what creates a linear vector space with v1, v2 and v3, because they are both they're all independent. Three vectors combinedly forming a vector space in which each component is independent is a linear vector space, real linear vector space. Okay, so option D is the correct one. If you substitute the values for C and D, option C and D, you can see clearly that they will come to 0. Okay, you can check it for yourselves. And I hope you guys understood this very well. For more videos, you get to this link t.me/CSIRNet Physics.